Okay, the next is tube. Okay, the tube diameter usually within the range of 16 mm to 50 mm. This is the typical range of the tube diameter. Okay, tube is located inside the shell. Okay, the smaller diameters are preferred for the most duty as they will give more compact and therefore cheaper exchanger. So the typical ranges are 16 to 25 mm. This is the most preferred for the most duty. And then the larger tubes are easier to clean. This is the advantages if we have the larger tube. And by using the cleaner using a mechanical method or will be selected for the heavily falling fluid. Okay, heavily falling fluid, that means such as if the fluid is more corrosive. Example, if we deal with the acidic or the corrosive chemical, that we can consider to have a larger tube. Okay, the longer tube will reduce the shell diameter, which will generally result in a lower cost heat exchanger, particularly for the high shell pressure. So for the high shell pressure, we will consider to reduce the to have the longer tube that eventually reduce the shell diameter. Okay, as a guide, if you start to design your tube, maybe you can consider to put at 19 mm for the trial diameter to start to the with the design calculation. Okay, these are the standard diameter for the steel tube. If we have the outside diameter about 16 mm, so the wall thickness could be either 1.2, 1.2, and so on. So basically, you may refer to this table to define your diameter and it give you the wall thickness. Okay, the next important is the tube arrangement because it will affect on the effectiveness of the flow arrangement of the fluid inside the shell. Okay, so these are the common layout. If we have the outside diameter of the tube about quarter inch, so basically you can choose either square or triangular, and this is the tube pinch inch. Okay, what is the tube pinch? Okay, first, this is the type of the layout. We have the square, triangular, and rotate square. So the flow basically will be this direction if we have the square. Okay, pinch is the diameter of the distance between the center of each tube. Example, if we have this particular flow type, so these are the flow arrangement that will flow or the on the shell part will flow to this direction. And if we have triangular, so basically this is the arrangement of the triangular. We have the triangle of the tube arrangement here that give another flow for the shell, and this is for the rotate square. Okay, triangular and rotate square patterns, which is basically have the higher heat transfer rate, but at the expense of a higher pressure drop than the square pattern. Okay, a square or rotated square arrangement is used for heavily falling fluid. Basically, it is for the maintenance purposes. So if we have square and also rotated, so it can be for the heavily fluid. Okay, to proceed the detailed design of the tube sheet layout, or we call as the tube count, you can use this equation. Example, to determine the number of tube, you may use this K1 dB times dB is the bundle diameter. Bundle diameter is the overall diameter when we have the total layout. Example, I have the shell here. Okay, this is my shell, and this is example YouTube. So basically, this is the total bundle diameter dB. And we have the tube outside diameter. This is the tube outside diameter. N1 is, and K1 is the constant for each equation. Okay, example, to determine number of tube, when you already identify what is the type of the pinch, whether triangular, square, and then you may use this to obtain the value of PT. And then after that, you can define the number of passes. Example, if you have a 4 number of passes, so the value of K1 should be 0.175, and now N higher than N1 is 2.285, and then insert this value to this equation that give you the number of tube and also the bundle diameter. Okay, these are the example of the number of passes. If we have 2 passes, so this is the design or the layout. If we have 4 passes, so basically the tube is inside here. So this is the buffer. Dash is referred to the buffer line. Okay, the tube passes is the is chosen to get the required tube side fluid velocity to obtain the greater heat transfer coefficient and to reduce scale formation. Or scale formation is related to the falling the tube. Okay, the tube passes is varied from 1 to 16, and usually we can apply 1 to 4 or 1, 2, and 4 for the common application. Okay, for the tube sheet, okay, the tube sheet thickness should be greater than the tube outside diameter to make a good seal. Okay, because we are also consider the welding part or sealing this tube, so we can consider the tube sheet thickness which should be higher than tube outside diameter. Okay, the recommend you may refer to the table or based on the IS 4503, which it can be followed to select the minimum tube sheet thickness. So we consider the minimum tube sheet thickness because we need to consider the bundle's clearance diameter as well. Okay, this is how you define your shell bundle clearance. Example, we have shell, and this is the tube part. So these are the bundle's clearance that you should consider. What are the bundle's clearance? Example, if we already define the bundle diameter, and if our design is fixed and tube, example, the bundle diameter is around 0.6, so you just drag here to give your shell inside bundle tube diameter or this range. Okay, the last is the baffle. Okay, baffle are used to increase the fluid velocity by diverting the flow across the tube bundle. So this is example, if we have the baffle here, so we can have the flow of the shell that give or increase the fluid velocity. And the distance between adjacent baffle is called baffle spacing. So the distance between the adjacent baffle here, we call as the baffle spacing. Okay, the baffle spacing of 0.2 to 1 times of the inside shell diameter is commonly used. So after you define your shell diameter, we can define the baffle spacing. Okay, these are the type of the bundle. We have cut segmental baffle. We have this or donut baffle. Okay, the design like donut here, and we have a orifice. So orifice, we have this particular layout or the design.